In the last class, maybe we just tried one operations, that is traversing.
Yes, ma'am.
Okay, and in today's class, we'll execute some other operations like insertion and deletion. Okay, so our next operation will be insertion. So first, tell me, did you find any problem in traversal? Did you find any problem in the algorithm or in that process, how we can process the uh, elements in an array?
No, ma'am.
No. Okay. So traversal was processing all the data, right? Traversal means we can process or access all the data elements from all the memory locations. That is traversing. Okay. And now another operation is insertion. That means if we want to add a new item in an array, we can do it. Insertion means adding a new item in the list or in the array. Okay. So suppose this is an array which is alphabetically sorted. So this array has some names, or the name of the array is name. Okay. And this array consists of, suppose the array size is 10, but it has only 5 elements. Okay, so the array is alphabetically sorted. So the first element is A, and then D, F, was I, then J. So how many elements are here? 5
Five.
elements, right? And their index value, their position is 1, 2, 3, 4, and 5, but the array size is 10. Okay, so 6, 7, 8, 9, and 10. So when we declared an array name, at that time it occupied how many memory locations? 10 memory locations, but we only stored how many data items here? 5
Five.
5
data
data.
items. And what is the lower bound and upper bound value of this array name? What is the value of LB and UB? LB, that is the lower bound, the minimum index value of the array, and upper bound, that is the maximum index value of the array. Although the size is 10, but we inserted how many elements? 5 elements. So 1, this is the lower bound, and 5 is the upper bound, isn't it?
Yes, ma'am.
Yes, ma'am.
But in insertion operation, actually, we don't need to know what is the value of this upper bound and lower bound. We need to know what is the array size. We need to know about n, how many elements this array has. So the size of the array is 10, and we stored how many elements? 5 elements. That means the array is not full. So if we want, we can insert maximum how many data items here? 5 more
10
items
items.
can be 5 more items can be inserted here, right? So if the array size is 5, at that time insertion is not possible. If the array size is 5, at that time insertion is not possible. But here we can see some empty spaces. That means we can insert some new item. Okay. So suppose we want to insert an item, or item equals to G. We want to insert another name that is G in this sorted array. So in which position we can insert it?
4.
In 4th position, right? We can insert any item in this array. I mean, we can insert it at the end of the array, or we can insert it at the beginning of the array, or we can insert it at any position of this, anywhere in this array, right? But it depends on which item we want to store, or this list or this array is sorted, so you cannot just store G in this position, in 6th position, right? So adding a new item at the beginning of the array or in this position is really easy, right? If the item value is suppose Z, we can easily insert it in the last position. At that time, we just need to know whether the array is full or not. If the array is not full, then we can insert it in which position? In 6th position, right?
6th position.
But if we want to insert G, at that time, at first we have to find out in which location, in which position we want to store it. Right? At first we need to know in which position that item is going to be stored and how many items need to be shifted right? How many items we have to shift. In this array, there are total 5 elements. So if we want to insert a data item here, so how many items will be shifted downward?
Two items.
2 items.
Two items. Two
Two
items.
items.
Right. So, but obviously we need an algorithm. We have to follow a process, right? So how we can start the algorithm or how we can start this insertion process? That first we need to know how many variables we need to know about this array. How many things we need to know? Obviously the name of this array, right? So what is the name of the array? The name is name,
Name.
right? And in insertion operation, another important thing is the size. What is the size of the array? So n,
10.
then yes. So another thing is we need to know which item or which data we want to store. So item, that is another parameter, and any other parameter we need here in insertion operation. We need to know on which array we are going to perform this insertion operation and what is the size of that array, okay, and which item we are going to store, okay, and is there any parameter we need in insertion operation?
The exact locations that which
Very
will be
good.
replaced.
Yeah, in which position we are going to store it, right? In which position we are going to store that data. Suppose k. Okay, and we need another variable also. Do you know why you need another variable? This k is the position where we can insert the item, right? But we need another variable for loop, isn't it?
Yes, ma'am.
Yes, ma'am.
Okay, so these are the parameters we need here. So our first step should be we need to check whether the array is full or not. At first we have to check whether the array is full or not, but here the array is not full, right? So if the array is full, suppose here there are total 10 elements, upper bound equals to 10, at that time it will show a message that is overflow, right? But here we can see some empty spaces here, so the array is not full. So what should be our first step in the algorithm?
Check the size.
Check the size. So how we can actually do, if suppose we need another variable, we have another variable I.
Yes, ma'am. Then we have
Another-
to run a
Yeah.
loop.
Suppose we have another variable I, why we are using it? For just shifting the value from one place to another place. Or for executing a loop, we need another variable, right? That variable can be I. So how we can initialize that loop variable I? If we want to check the size of the array, at that time we have to initialize it as I equals to n, isn't it?
Yes, ma'am.
This is our first step, set I equals to n. And here n is the size of the array, right?
Yes, ma'am.
Yes, ma'am.
So these are initialization step. And step number 2, since the array is not full, so we can place any item in this array, right? So now here we can write another step, that is repeat steps 3 and 4. Then we need to put a condition, right? So repeat steps 3 and 4. So what should be the condition? What should be the minimum value of I?
Ma'am, I less than or equal n.
I less than or equal n. We already initialize I as n, right?
Yes, ma'am.
I equals to n. Now after that, we need to set a condition. We need to set a condition that how many times we are going to use this loop.
Madam, 10 times, so I will be minimum 1.
Minimum 1.
Yes.
Why 1?
Reducing from
We
10
need to
1.
know what is the value of k. K is the position where we can insert item. That means
Sir.
our condition should be related to k, right? right? We have to create relationship between I and k. So what should be that relationship? Here I, we have
Zero,
already
ma'am.
initialized it as n, I equals to n, okay? And now we can set a condition where we can create a relationship between I and k. K is the position where we can insert the new item, and k equals to 4. So what should be the condition? Repeat steps 3 and 4 while obviously I greater than or equals to k. What is the condition? Repeat steps 3 and 4 while I greater than or equals to k. That means we're going to repeat these steps how many times? When the value of I is greater than or equals to k. Here k equals to 4. So we'll repeat these steps for which positions? For I equals to 4 and I equals to 5. This is our array, right? N equals to, what is the value of n here?
10.
10.
N equals to 10.
Yes, ma'am.
N equals to 10. Okay, so let me clear these things. So repeat steps 3 and 4 while I greater than or equals to k. So from where we'll start working on this, I mean, from where we'll start moving characters or moving data. The
Madam,
condition
from
is
K-
while
From the
I, from
10
why
reversing
10?
order.
Look at
ma'am,
this.
from
Look at
4.
this. Why we're doing this for moving some data items, right? And it's not 4. Here actually n equals to 5.
Yes, ma'am.
Here n equals to 5, isn't it?
Yes, ma'am.
From where we will start shifting the data item from, this is our last data items in this array. Although the size is 10, but we have only 5 elements, and these are some blank spaces, empty space, right? So we don't need to shift any characters from those position, because this position doesn't have any characters or data. So we can assume that here actually n equals to 5. So we'll start from which position? 5. The initial value of I is 5, right? And how many times or how many data items should be shifted towards downwards?
Two.
How many data
Two.
items?
2 times.
I greater than or equals to k. The condition is I greater than or equals to k. So we'll start shifting the characters from which position? From 5. After that, we'll shift the data item from which position? 4. Isn't it? After shifting
Yes, ma'am.
this character, then we can shift which one? Position 4, the data items of position 4, right? And do we need to shift the data item of position 3? Do we need to
No,
shift?
madam.
No, because this is the condition while I greater than or equals to k, and here the value of k is 4. So 3 is not equals to or greater than k. So we can shift how many data items from which memory locations? Only 2 data items from the memory location 5 and 4. And after shifting the data item from one memory location, then we have to decrease the value of I, isn't it?
Yes, ma'am.
Yes, ma'am.
When
Yes,
we
ma'am.
initialize any variable as 1, at that time we just increment that variable. But here we are initialize it as the maximum value. The maximum value is 5. So now we have to decrement the value of I, isn't it? So step number 2
Madam,
is,
not.
yes,
No,
it's
madam.
not clear.
Yes, ma'am. Not clear.
Okay, let me just
I
write
thought-
the algorithm first. Okay, so step number 2, repeat steps 3 and 4 while I greater than or equals to k. And then the next step will be step number 3, set j equals to j minus 1. Okay. So this is the array, right? What
Yes,
is the
ma'am.
value of n? This array has
J.
5 elements. This array is 5 elements. So here n equals to 5. And we have initialized the variable I as 5, right? Here I equals to n. That means the initial value of I is 5. So at first, this algorithm will shift the data from which memory location? 5. isn't it?
Yes, ma'am. Madam, but what about K? We haven't initialized K.
Why we need to initialize it? This is a position where, I mean, we're going to store the item. What is K
K
here?
position.
Just let me draw the figure again. This is our array. Okay. And the name of this array is name. And what is the size of this array? The size is 10, but it has how many elements? 5
5.
elements.
5.
5, 6, 7, 8, 9, and 10. Okay. And array insertion is possible when the array is not full. Okay. So this array has 5 elements. So these are the memory location 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. And the first data is A, then C, E, then I, and J. Okay. And now we want to insert a new item. And what is the value of that item? Item equals to
G.
G. Okay. So these array is alphabetically sorted. That's why we cannot just insert the new item in this empty space, in this available space. Here we can see that the array size is 10, but it has only 5 elements. So that means 5 more elements can be inserted here. So if we want, we cannot just simply put that item in memory location 6 because it's alphabetically sorted. So now we have to find out that position where the new item G can be inserted. So if it's alphabetically sorted, that means this is a place, this is a position where G can be inserted because G is greater than E and it's less than I, right? So here K equals to 4. K is the position where the new item should be inserted. Is that clear?
Okay, ma'am.
So this
Yes, ma'am.
is K. So now we need an algorithm. Suppose we are doing this for which operation? Insertion operation. Okay. And how many parameters we need here? At first, we need to know the name of this array, which is name, and then the size of the array or the maximum, how many data elements are stored here. So here n equals to 5. 5 item is stored here, right? And then we need to know the value of item, that is which data will be stored here, and then in which position the item will be stored. Is that clear? So these are 4 parameters of this algorithm. And now we can start the algorithm. The first step is we need to initialize the loop variable. The first step is set I equals to n. Set I equals to n, that means we initialize the loop variable I as n. What is the value of n here? N equals to 5.
5.
This is insertion operation. That means we have to create some space for inserting the new item. If we want to insert it here, and we can see that position 4 has already one data item. So that data item should be shifted where? To downward, right?
Downward.
Yes.
Yes,
So
ma'am.
that's why we have to start this insertion operation from which position? From the highest position, from 5. So we can initialize I as n. I goes to n, or we'll start the algorithm from which position? 5th position, where the data item is j. Right? So now we have to set a condition here. So what should be the condition? We can write repeat step 3 and 4 while I
Guys, can you hear me, ma'am?
Yes, ma'am.
Yes, ma'am.
Yeah, I'm really sorry for this network problem. I mean, this is really disturbing. Okay, so I have to prepare it again. I have to draw the figure again. Okay, so now you tell me what was the first step in insertion operation? What is the first step?
Set I equals to
Initialization.
n.
I equal to n.
Okay, set I equals to n. So here, what is the value of n if we have 5 data elements?
5.
5.
5.
N
Very
equal
good.
to 5.
Yeah. So the initial value of I is, that means 5. So these are our data item. Okay, some other spaces here. So we want to insert which item? G. Okay, and this item G will be inserted in position 4. So K equals to 4. So our first step in this algorithm is set I equals to n. That is our first step. So n equals to 5 because this array has maximum 5 elements. So the initial value of I will be 5. Okay. After that, step number 2, repeat steps 3 and 4. What is the condition?
K less
I
than
less than
equal
equal
K.
K.
I greater than or
I
equal.
greater than or equal to K.
Very good. I greater than or equals to K.
K.
Okay. So when I equals to 5, at that time, this condition is true or false? When I equals to 5, this condition is true. So if this condition is true, now we can shift the element of that position 5 to its next position. When this statement or this condition is true, that I greater than or equals to K, this condition is true, now we can shift this element where? To its next memory location, right?
Yes, ma'am.
The data item here now, suppose the name of this array is n. So n of 5, the position is 5 equals to j, right? In this position 5, which data item is inserted or stored? J.
J.
So when this condition is true, now we can shift j to its lower position, that is in 6th memory location. Is that clear? So here step number 3 will be set. What is the name of the array? N. Okay, j plus 1 equals to nj. So now look at this jth element here. What is the value of, sorry, it's, we took the variable I, not j. Okay, so what is the value of I? The value of I is 5. So this 5th element will be shifted to which position? 6th position, I plus 1. When I equals to 5, at that time, the data item of that position will be shifted to which position? In I plus 1
Sixth
position. That is in 6th position. So now j will be shifted here. Okay, so an empty spaces has created in this memory location 5. So what is our next step? The next step is step number 4, set I equals to I minus 1, right? The next step will be set I equals to I minus 1. So what is the new value of I now? The previous value was 5. So after
4.
increment operation, the new value of I will be 4. Then again test the condition. 4 equals to 4, that is true. Now we can shift the data item from which memory location? From 4th position to its
5.
memory
Fifth.
location. Hence execute step number 3 again. It's been again. N of I plus 1 equals to n of I. So here, when I equals to 4, n of I equals to I, right? Sorry, n of 4 equals to I. This data item I will be shifted to which position? N of I plus 1, that is in 5th position. Is that clear? So now this I will be shifted to memory location 5. So we can see an empty space in memory location 4. Again set I equals to I minus 1. Now the new value of I will be 4 minus 1 equals to 3. and 3 is not greater than or equals to 4. When this condition is false, now we can insert the new item in which position? In fourth position. We can insert G now in fourth memory location. And that is the insertion operation. Is that clear?
Yes, ma'am.
Okay. So our first step was initialize a variable. Initialize the variable I, and the initial value of I is
5.
the maximum value of this array, right? The maximum index value is 5 here. So I equals to 5. Then repeat step 3 and 4 while I greater than or equals to k. And k is the position where the new item will be inserted. Okay. So now we can repeat step number 3 and 4. Step 3 is if the condition is true, then shift this ith data item to which position? I plus 1. Right? We can continue this process how many times? Until this condition is true. Okay? So after inserting a new item, now we can see that this array has how many data elements? 6 data
Six.
elements, right? So now here we have to reset the size of the array. Initially n equals to 5, that's why we have to reset n. Okay, so here reset n equals to n plus 1. So now this array has how many data items? 6 data items. Is that clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
What about the others? Or you can just do one thing. You can practice another one. Suppose.
Yes, ma'am.
Yeah.
If we practice, then it will be clear, more clear.
Okay. So you can see an example here. Just look at the figure A. In this figure, an array is given with how many data items? 5 data items. That is Brown, Davis, Johnson, Smith. Okay. So if you want to insert a data item, suppose we can see 3 different cases here, isn't it?
Yes, ma'am.
Yes, ma'am.
In figure 4, we can see that the item is Wechner, right? What is the initial value of this name? W.
Yes.
Yes, ma'am.
That's why the new data item can be inserted at which position? In position
3.
right?
Third place, madam. Because 4 is entered.
Okay, just forget about this one. Suppose this is our array, okay? And now if we want to insert a data item, or suppose the item name starts with Z. If the item name starts with Z, then we can insert the data item where?
6.
In memory
Six.
location
Yes.
6, right? Or suppose in another case, we want to insert a data item whose name starts with A.
In the first position.
First position. So in the previous case, when we inserted the data item in memory location 6, we didn't need to move or shift any data item. When we inserted a data item at the end of this array, right, at that time, we didn't need to insert any data item, right? But what about, suppose for this array, now the data item will be inserted in where? Because we need to find out the complexity, the time complexity. Okay, so this is the array with suppose 4 data items. Okay, 1, 2, 3, and 4, and the data item is A or B, then D, E, and F. Okay, so if the new data item is G, where you can insert it, you can insert that new data item at the end of the array here, right? So at that time, we didn't move to any data item. So we have to find out the time complexity for this case. And another case is, suppose the item value is A. And this list or array is alphabetically sorted. So we have to insert it where? We have
First
to
position.
insert it at the beginning of the array. But already we have a data element here, that is B. So if we want to insert a new data item at the beginning of the array, at that time we need to move all the existing data items of that array, isn't it?
Yes,
Yes,
ma'am.
ma'am.
All these data items need to be shifted, right? Or what about if the data item, or we want to insert it in the middle of the array? At that time, half of the data items need to be moved. So there are three cases when no data items need to be shifted, and another case is when all the existing data items should be shifted, and another case is we can only move half of the data items of the array. So now find out what should be the time complexity for the first case, second case, and third case. What is the time complexity of these three different cases? So this is your homework. You have to find it out because you know how to calculate time complexity. Is that clear? That is your homework. So here in this example, now if we want to insert three data items, one is Ford, that is the name starts with F, and another is Taylor, the name starts with T. So how many steps we need, or how many times the loop will be executed, or what is the process of inserting two data items? This is the array we have with 5 data items. Now we want to insert how many data items? Two data items. One that name starts with F, and another is Taylor, that is starts with T. So what is the process? How we can insert it? Insert this two data item. Hello.
Yes, ma'am.
Yes. So tell me from where you can start. Two data items need to be inserted. One is suppose F and another is T. So for the first data item, just identify the position should be. Hello?
Yes,
Yes,
ma'am.
ma'am. I can hear.
Yeah, what is the position of this F?
Three.
Third position.
Third.
3,
Yeah.
right? Okay. Then what about T?
Fifth
Five
position.
feet.
Fifth position. But is that possible to just, define or assign two different values to one variable K? Because after inserting the previous data item F, the size of the array will be changed. At that time, maybe
Yes,
the
ma'am.
position of 5 is not, the position of this name is not 5. So at the
It
time
will
of,
6.
It will 7 because we have to add 2.
yeah, so how we can actually do it? Multiple data items in an array.
Madam,
This
using
is
two loops for a
using
test
two
case.
loops.
Yes, ma'am.
But we are working on only one array, right? After
Madam,
inserting one data
then
item, the value, the memory, the position will be changed. Suppose this is B, then C, and G, S, W. Okay, so this is the array, and we want to insert two data item. One is F, and another item is C. So can we insert these two data items at a time? Can we just identify the position? Suppose F will be inserted in this memory location 3, and T will be inserted in 5. Can you do it?
madam, at once. Program will be
Yes, we can
executed
only
for
insert
once.
one item at a time. After inserting F, then we can insert C,
Yes, ma'am.
right?
In that case,
So
madam, can we use loops for two times? Because here two items, so the outer loop will be go for two times, and inner loop will just insert.
if that two loop, suppose they're executing at the same time. So what will happen? The first one, it will take these variables. Suppose for first loop, the value of k will be 3, and for the second loop, the value of k will be, or we can use another variable and it will be 5. But is that true? after the execution of the position will be changed. So at that time, if
Yes,
the
ma'am.
second loop inserts a data item at memory location 5, it will not be correct.
It will be
Madam,
6.
So it's not
at that
possible.
time we can do traversing again.
Okay, you can do one thing. You can just practice. You can do one thing. Just check it whether your theory is, process correct or not. You can just write the program in code blocks or just try in any other programming language whether it's possible or not. Okay,
Okay.
Okay, ma'am.
is that clear? So I hope insertion is clear to you now, right?
Yes, ma'am.
Yes, ma'am.
The next operation is deletion. If we want to delete an item from the array, then how we can do it? Suppose this is the array with 5 data items. The first data item is B, and then D, I, J, and L. Okay, so these are 5 data items, and suppose the size of the array is 7. So in deletion operation, do we need to actually know the size of the array or the maximum
No, ma'am.
value of the array?
No, ma'am.
No,
No,
ma'am.
we don't need to know it, right? What is deletion operation? That means we can delete a particular data item from this array, right? So in deletion operation, how many things we need to know? Obviously, the name of the array. Suppose the name of this array is LA, that is linear array, okay? And then
Item.
we need to know which data item will be deleted. That is the item. Suppose we want to delete I. We want to delete I. Then we have to find out the
Position.
position or memory location of that item, right? So here k equals to 3. Okay, so how many parameters we need here? We need to
3
know the name
parameter.
of the array, LA, and then the item and k, right? So what should be the first step of the algorithm? Obviously, we need loop variable. We need the loop variable, right? But do we
Yes, ma'am.
need to actually initialize the loop variable here? In deletion
No, madam.
operation, which item will be deleted, it's one kind of fixed, right?
Yes, ma'am. Index is given.
And we have to mention it in our algorithm. That is which data item the algorithm is going to remove. We have to mention it here. That means in step number 1, we have to declare it which item is going to be removed, right? So in step number 1, can we just write set item equals to LA of k? Can you write it? Step number 1, set item equals to LA, that is the name of the array, and k is the position of the array. Step number 1, item equals to LA of k. Here item equals to I, and in which position we can find it? In position
3.
2, right? So I equals to LA 3. This LA is the name of the array, and 3, that is the value of k or the position of the item, and the item value is I. So we want to delete this item. So this is our step number 1. So what is step number 2?
Madam, shift, fill the gap.
Delete.
Yeah, so now the data item will not be shifted downwards,
Upward.
right? The data items will be moved upward. After deleting this item now, an empty space will be created here, right? But array is linear data structure. So we cannot hello.
Yes,
After
Hello,
Yes,
ma'am.
ma'am.
Yes,
yeah,
ma'am.
after deleting this data item, there will be an empty space, right? So how we can fill it up? Obviously, by
Shifting
moving
up.
or shifting the
Upward.
lower data item, right? Upward. So we have to move these upward, right? So after shifting J to its upper position, now another empty space will be created here. So we can fill it up. That I mean L can do it, right? So L will be shifted to this position, isn't it?
Yes, ma'am.
Yes, ma'am.
Okay, so how we can define it here? How we can define those things in the algorithm? We have a variable, suppose I. So how many times or how many data items will be shifted upward?
Madam, 3 minus 5. Uh,
3 minus 5.
mm,
In algorithm, actually,
no.
we can't write 3 or 5. We have to use some generalized term here, right?
Yes, ma'am.
We can use some
K
general term that
minus
is
K minus L.
k minus n.
Where is N?
What is the
madam?
value of a? The value of a is 3 and n is 5. Okay, now tell me, actually, we need to know the value of n, isn't it? Actually,
ma'am.
we need n
Then-
also. Yes. Yeah, we need n also. Because without n, we cannot set our condition, right? So what should be our condition?
K minus.
From which memory location we will start? First tell me. From
3.
very good.
madam.
That means from kth, right? Kth position, isn't it? So
Yes,
we
ma'am.
can say that repeat for I equals to K2,
K.
I equals to K2,
K minus. No.
why K minus? Again, look at this array. This array has how many data items? 5 data items, that is n equals to 5, right? And if we start from this position, from kth position, right? So when I equals to k, or after deleting the item from kth position, now there is an empty space, right?
Yes, ma'am.
So which data item will be shifted here?
4. 3.
Obviously 4. When j equals to here, can you
Up to N, madam. The condition
Can
is
we
be
just
I
write-
less than equal N.
LA I, let me write it here. Look at this. After deleting the data item I, there is an empty space, right? So can we just write LAI equals to LAI plus 1? When I equals to 3, we will start from I equals to k, right? And what is the value of k? The value of k is 3. That means the initial value of I. Initial value of I is 3. Right? And the next step is assign the value of LAI plus 1 in which position? LAI. LAI equals to LAI plus 1. That means here LAI plus 1, that is LA4 equals to J. J will be shifted to which position? LAI, that is
Third
here.
position.
In this position, right? When I will be deleted, now J can be shifted here. That's why LAI equals to LAI plus 1. That means the fourth data item will be shifted to which position? In third position. Isn't it?
Yes, ma'am.
Okay, so now there is an empty space, right? So we can move the next data item in this position, right? So what should be the condition? What
I
is
less
the
than equal N.
from I equals to K to
N. Madam,
N.
condition should be N, yeah.
So if the condition is N, then what will happen?
Up to 5 it will run.
Sure. Just explain it. We started from which position? From kth position,
Kth position,
right?
yeah.
After moving this
One is
data to its
minus
up. Sorry?
Madam, N minus
This is
1.
an empty space. Very good. N minus
minus
1.
one.
That is the condition. Very good. The condition is repeat for I equals to k to n minus 1. Repeat for I equals to k to n minus 1, that is move I plus 1 element upward. This I plus 1 element will be shifted upward. Isn't
Yes,
it? That is step number. Hello.
Yes, ma'am.
Yes, ma'am.
Now is that clear how deletion operation can be performed on array? Our first step was set item equals to, what was the first step? Item equals
Item
to LA k.
to A K.
That is our first step. So if this is the array with suppose 4 data elements, so 1, 2, 3, 4, and the data items are B, D, G, K, and here suppose we want to delete G. That means item equals to G, right? And what is the value of K? K equals to 3 because G is located in which memory location? In memory location 3, right? So what is the next step of this algorithm? The next step is repeat for I equals to k to n minus 1. What is step number 2? Repeat for I equals to k to n minus 1, right? And then step number 3, LA I equals to LA I plus 1. Okay. So if we delete kth data item, after deleting G, there is an empty space. Okay. So now kth item will be shifted here. So after shifting k to this position, now there is an empty space where in memory location 4, right? So initially this array had how many data items? 4 data items, but when one data item was deleted, now we have to reset n again, right? So what will be the new value of n? How many data items are here? 3
Three.
data
n
items,
minus
right?
1.
And reset n
N equal to N minus
n
1.
equals to n minus 1. That is deletion operation. Is that clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So in insertion operation, we just inserted new data item. That's why the data item should be shifted downward. But in deletion operation, we are deleting some data from a particular position. That's why some data items should be shifted upward. That is deletion operation. So I hope these 3 operations are clear to you, right? So far we have discussed only 3 operations on array. One was traversing, then number 2 insertion, number 3 deletion. Okay. So in our next class we will start 2-dimensional array. Okay. So that will be the last topic from array. Then we will start linked list. How many operations can be performed on array? 6 operations. The first one is traversion, and then insertion, deletion, searching, sorting, merging. We'll discuss the other operation, that is searching, sorting, and merging later. At first, we'll complete all the insertion, deletion, and traversal operation for all the data structures such as array, linked list, and second queue. Okay?
Okay, ma'am.
And I'll take the first term exam on 17th February. Your first term exam date is on 17th February. Is that okay?
Yes, ma'am.
Okay, ma'am.
Okay. Now please response 1,
Yes, ma'am.
2, 3.
Yes,